All right, let's jump right in. We're going to talk about a huge idea in AI, one that I think often gets overlooked. It's all about building systems that don't just work. They have to be able to adapt and survive out in the real world. And that brings us right to the title. No model is an island.
Whenever you hear about some incredible new AI model, what do you picture? It's easy to think of it as, well, this. A perfect, pristine little island of intelligence, right? A totally self-contained, brilliant creation that just does its one job and does it perfectly. It's a really appealing image, but honestly, it's also dangerously misleading.
And this idea isn't new. In fact, the poet John Donne said it best almost 400 years ago. He was talking about how people need community, how we're all connected. And what's so wild is that the exact same principle applies to our most advanced AI. No model, just like no man, can truly stand alone. So, okay, let's really challenge that first idea. What if your model isn't an island? What really happens when we stop thinking of it as this isolated thing and instead see it for what it is? Something that's deeply connected to this huge continent of data, other systems, and even people.
And that question right there brings us to our first big topic. If we really want to get why a model can't be an island, we have to pull back the curtain and look at all the hidden connections, this invisible web that pretty much every AI model depends on. Think about how software used to be built. Way back, you'd often get something like what you see on the left, a single, massive, all-in-one block of code, a monolith. But that's just not how we do things anymore, especially with AI. Modern software looks a lot more like the image on the right. It's modular. It's made up of all these smaller, interconnected pieces that all have to work together. And hey, there's a really good reason we made that shift. Modular systems are just better. I mean, they're way easier to maintain and update. You can grab components and reuse them somewhere else. And this is a big one. When something breaks, you can test and fix one little piece instead of trying to debug the entire massive thing. So here's the key takeaway. This modular approach is what makes today's complex systems even possible.
Okay, so let's tie this back to our AI model. It is definitely not self-sufficient. It's always talking to a ton of external things. It's pulling in data from other models, it's depending on data sources that other teams manage, it's reacting to what users are doing. It's really part of a living, breathing system. But here's the catch. That deep connection, the very thing that makes these systems so powerful, it's also their biggest weakness. It introduces a major vulnerability. So let's take a look at what happens when the real world and all those systems our AI depends on inevitably changes.
Let me tell you a quick story to make this real. Imagine you've built a pretty simple but super useful AI model. Its entire job is to predict when you need to grab an umbrella. Now, your little umbrella model isn't some super genius meteorologist, right? It doesn't know the weather on its own. It has to get its data from another, much more complex weather prediction model. We'll call that the upstream model. And that right there, that's its main dependency. So everything's going great, and then one day you get absolutely soaked on your way to work. The app was totally wrong. It just stopped being accurate. So you go and check your code, but you haven't changed a thing. So what gives? The whole thing seems to have failed out of absolutely nowhere. Well, after a whole lot of digging, you finally find the culprit. It turns out another team, the one that owns that upstream weather model, retrained it. And you had no idea this was happening, they accidentally used a data set from a few years ago that had a really unusual drought. And this just shows the problem perfectly. Because that big weather model was trained on data with way less rain than usual, its new predictions are totally biased. It now consistently underpredicts the chance of rain. And just like that, your umbrella app is completely useless. A tiny, invisible change way upstream caused your model to completely fall apart. And look, this isn't just some made-up story. This kind of thing happens all the time. The real world is always changing. Data drifts, user behavior shifts, other systems get updated. And if your AI is built like that fragile little island, sooner or later, the tide's going to come in and wash it away. It has to be designed to adapt. So that leads to the million-dollar question, right? How in the world do you build systems that can actually handle this constant change? Well, that's exactly what we're going to get into next, designing for adaptability. A huge part of the answer lies in a discipline called MLOps. That stands for Machine Learning Operations. And if you think about it, MLOps is kind of like the engineering crew that builds the bridge from our lonely model island over to the mainland of real-world production. It's basically a whole set of practices designed specifically to handle all this complexity and build AI systems you can actually rely on.
And a good MLOps workflow isn't just a one-and-done thing. It's not a straight line, it's a continuous loop. Sure, it starts with getting your data ready and developing the model, but the crucial part is that it doesn't stop there. From there, you automate the whole workflow, and then you enter this phase of constant deployment, monitoring, and tuning. It's this never-ending cycle that lets a system spot when the world is changing and, hopefully, adapt on its own.
Now, when you really start thinking this way, something amazing happens. You unlock something way more powerful than just one stable model. You actually start to create a thriving AI ecosystem. The whole goal just shifts. You're not trying to protect your one little island from the waves anymore. Instead, you're building out a whole network of capabilities, a continent, really, of interconnected tools that all work together, learn from each other, and actually get stronger over time. And the great news is, building an ecosystem like this is easier today than it's ever been. We have these incredible tools that are basically the building blocks. You've got massive foundation models like Gemini that give you a knowledge base to start from, platforms like Model Garden where you can find and plug in pre-trained models, and specialized services like Vertex AI Search. These are the pieces you assemble to build that truly adaptable network. So you see, instead of that fragile, isolated island that we started with, the end goal is something that looks a lot more like this: a dynamic, interconnected, always evolving network. This is a system that isn't just designed to survive change, it's designed to thrive on it. So, I'll leave you with one final question to think about. When you look at the AI systems you build or rely on every day, are they really built to weather the storm, to handle a constantly changing world? Or are they just beautiful, isolated islands waiting for the tide to turn?